All right, so we're going to be rebuilding a warm-up regulator found on a lot of the K-Jet, Bosch K-Jet cars. Specifically, this one here is out of a 1975 Porsche 911, and the 2.7 with the magnesium engine. So pretty special car. And this car has one of the earlier style Bosch K-Jet. The difference between the K-Jet and the KE is the KE cars have a EHA, it's called. It's a regulator that mounts right on the side of the distributor. The older cars use this warm-up regulator that has a small heating element inside and does rough control of the fuel pressure between the upper and lower diaphragms on the fuel distributor, and will provide a warm-up fuel change as the car warms up to give you optimal fuel efficiency. Some symptoms of a fuel regulator that's acting up is either your car runs rough when it's cold, runs rough when it's lean, fuel mixture's out of whack, or you can't properly dial in the fuel mixture using a O2 sensor, wideband O2 for example. As the car warms, when the car's cold, the fuel mixture is good, slightly rich, so the engine doesn't stall out when it's running. And then as the car warms up, it starts to lean out too much. So we're going to open this one up. This one had an issue where we were able to tune the fuel mixture when the car was cold, and a good fuel mixture for cold start. However, as the car warmed up, it got excessively lean, especially under heavy engine load, which we verified on the dyno. So we're going to disassemble the unit. We're going to do some checks. First, we're going to do some checks first, disassemble the unit, and then we have a K-Jet rebuild kit here with all new gaskets. This is a universal kit, so there will be some parts that we don't end up using, as they're all the regulators do have some slight differences in between them depending on the car model. But you see we got some copper crush washers here, a gasket plate, some new springs, O-rings, and some internal bolts, and a new base gasket there. So first thing we're going to start is...
Jack, can you tell about what you're going to do about this drilling?
So one modification that we're going to do with this is... these are not designed to be adjusted from the factory. Also, you can see there's no real adjustments externally, and internally there really isn't much adjustment for these warm-up regulators. So what we're going to do is there's a common modification for these. I have a diagram here where we will add a metric screw threaded into this insert here that will allow you fine adjustment of this plate holder pin, which will then give you some adjustment, fixed adjustment obviously, because it will fix, once you set it, you fix it, on the bimetallic strip that controls the in and out fuel pressure. So we'll get into details of that after we're done dissecting the unit. It is a modification that would be ideal on units that is disassembled, so you don't get metal shavings and flakes done. It is relatively simple when you have a full machine shop, but this is a modification that could be a bit difficult if you have just a basic drill press. However, drilling in the center of that plate should not be too hard, and we'll deal with that when we get to it. So first things first, we're going to, even before we open the regulator, is we're going to check the resistance of the heating element inside this unit. So there really isn't any polarity specifically on this pin, but it's a 12-volt heating element inside that causes the bimetallic strip to move in and out as the car warms up. And I believe on this specific car, this is activated by, I believe, a temperature switch on the motor, but I can't remember exactly. There's been a few different changes in different applications for this. Some of these on Mercedes, for example, might be controlled by the ECU depending on engine temperature. Some of these, I believe, might be PWM to control the heat input. They all vary. A lot of the vehicles I deal with are the KE system, which just have a EHA they call it on the side of the distributor, and that does all the enrichment and derichment adjustment on the fuel distributor. So first thing we're going to do is we're going to check the resistance on the heating coil on these two pins, just to make sure that we have we don't have an open coil. So we're just going to put it on continuity test, and it'll give us a rough adjustment. Ideal resistance range should be between about 15 to 30 ohms. Some of these do have a, there we go. So we got a little bit dirty connection here. So we have 36 ohms. It's a bit on the higher end, but we'll see when we open it up if the heating element's been overheated or whatnot. But that is on the upper end of the spec, but it's definitely not an open circuit, so we're good there. So what we're going to do is grab a flat blade screwdriver, and on the bottom of the distributor there's these flathead screws. We're just going to open it up. There. Yeah, we'll let the screws, the nuts fall out. So it's actually different manufacturers. Some of them have socket cap screws on the bottom. This one's flat blades. Okay, there we go. And before we go any further, the model number of this specific fuel distributor is, the Bosch part number is 0438140009. And again, this is the specific fuel distributor for a 1975 Porsche 911 2.7 with the K-Jet fuel injection system on it. And this engine's actually a magnesium engine, which as you will probably see on the other videos, we've done an extensive rebuild on and shown some of the quirks and interesting features of the magnesium block engines from Porsche. So we'll open it up here. There's actually two halves of the diaphragm. This one here looks like the pin was loose inside, or it probably fell out when I pulled it apart. And as you can see, there's some gunky grease on there. You do put a little dab of grease to hold this pin in during reassembly, but you know, thick aged grease is can cause things to bind. This car has been stored for about 14 years, and it was nasty. This is the last part of the fuel system that we are going to take a look at. The rest of the fuel system is flushed out, but it literally had green, gunky, the most nastiest fuel I've ever smelt coming out of it. So obviously we do expect that maybe the internal diaphragm seats are stuck, or there's gunk in there that would either never come out of the system by running the engine, or would take many years to slowly dissolve, especially on a car that's not driven every day. So here we have the pin plunger assembly of two springs, and this base diaphragm, I believe, comes apart. There's a gasket in there with, I believe, this lower pressure plate will fit in there. So let's put the old parts to the side here. Always be careful when splitting case halves. These are sealing surfaces. Let me see that little flat plate here. I remember that I did actually take this unit apart before. I'll just do a quick inspection on the car. I don't think I was able to get this one apart. Don't really want to twist it, but we might have to put it into a vise and give it a slight tap. So I'll just go do that and I'll be right back. Okay, so we got the lower half of the fuel regulator apart, and as you can see, we have a rubber diaphragm here with this. This is a atmosphere regulator plate. As you can see, it's open to the out in the bottom here to atmosphere. I believe so. I don't believe this connects to anything on the car side. Obviously, different vehicles have different applications on how they regulate the fuel. So in our kit here, we have a brand new plate diaphragm.
Show them about all the dirt.
As you can see here, there's a fair bit of crud in the bottom. We will be putting this through the our ultrasonic bath to give it a quick clean and get rid of any of the nasty particles. This half here, we can peel off the gasket. We have a replacement gasket, so most likely this is going to tear as we take it apart. Let's adjust the camera. There we go, right there. So we'll take this off, and hopefully the gasket stays in one piece. A couple little particles left behind. We'll just do a quick clean on the surface plate here with some 1000 grit just to clean it up. or we can use a razor blade. We'll try the razor blade first. You've got to be careful using razor blades so you don't nick the surfaces. This is a sealing surface that you'll want to keep as pristine as possible. You can see the old diaphragm is pretty rock hard. The new one's nice and soft. So toss that to the side, and let me just grab a blade here. Give it a quick clean. Come on. There we go. It's also a good opportunity. You can remove any nicks or high spots on the part. I had a bit of a fun time trying to remove the two halves. Always need to be careful using this method that you don't dig into the flat surfaces. But, I've done this a few times. Yeah, we might run this on some sandpaper quickly on the surface plate just to clean it up. Obviously not everybody has that, but if you do, use it to your advantage. Okay, we're trying to give it a quick sand. I've got a piece of sand over here. This is 1000 grit. Peel this back. Got a little bit of W40. Actually, I've got some aluminum tapping fluid here.
What is that you're putting there?
This is just an oil to help prevent the sandpaper from clogging up when you're running the surface across it. So I just want to spread, make sure there's no particles underneath. Just give it a quick cleaning. Take a quick look. Oh yeah, much better.
What kind of a plate is this?
This is a surface plate, so it's a precision surface plate used for machining, and it's usually used for measuring up parts within thousandths of an inch, half a thousandth of an inch. So it's this plate itself is actually about 36 by 24, and it's actually a fantastic working surface too if you're careful working on it, so you don't try and nick the surface or destroy its accuracy. So. Let's just give it a quick wipe. Oh yeah, I cleaned it up a fair bit. We still got a little bit of residue, but you know what? That's also a little bit of corrosion coming in from where the screws are from the outside atmosphere, but that's good enough for now for this part. And again, we'll run these through the ultrasonic before assembly. Okay, so that's these two parts here. We'll sit these here. Okay, so this is inside the fuel distributor here. See, there's a heating element here, and there's a bimetallic strip, kind of like a bimetallic strip. I believe this piece right here. So it's very minute movement, but as this heating element heats up, causes this arm to move up or down, and moves the pin in and out inside this assembly here that controls the flow in and out of the fuel ports here. And then this in turn controls the fuel pressure between the upper and lower manifold on the fuel distributor on the engine. And in turn that will enrichen or lean out the fuel mixture as the engine is cold to warm. So we're going to disassemble these fittings, and always keep note of the crush washers that are in between. And you can see this port here has a screen in the bottom to catch any particles floating in the fuel, just because there's very small orifices inside this valve body assembly here. And we're going to remove this clip that holds the the connector for the heating element. So be careful, because some of these connectors, I mean, the car is almost 40, 50 years old, depending on how old the car is. Plastic does get brittle, especially in an engine compartment environment. A pair of tweezers here. And you don't put too much stress on that connector. I believe this is still a standard, I think they call it EV1 or EV12. I always get the two mixed up. So connectors actually haven't changed. This is fuel injectors. A lot of cars use these as a fuel injector connector. Not so much in the last 5 years, but most cars in the 90s to mid 2000s use this Bosch style connector for fuel injectors actually. And it's interesting they kept the standard for that long. Okay, so that loosens up the connector, as you can see. Next, we're going to loosen that bolt, and the whole assembly will come out. Okay, so here we go. We have a 10mm socket, and famously always lost, but I happened to find one almost right away. So we're just carefully loosen that nut. You can see we have a nut and two washers. One I believe would be a lock washer and a standard washer. So let's set that to the side. So this whole assembly should now come out of the fuel distributor. Just be careful not to damage the wiring. It is aged, and this does see somewhat a bit of heat. So there we can see the bimetallic strip on the top, and that influences this whole bar to move in and out. And as you can see here, this one's actually rated at 35 ohms plus or minus 7.596. Very specific. And I believe we had what, 36 ohms. So right on the money. Heating element's good. There is a chunk missing out of it, which is actually kind of odd. Not floating inside the fuel distributor at all. So that probably happened at the factory and no one caught it. Very interesting. See, this was built in the 70s, so
75 September.
Someone probably got in big trouble for that if they got caught. Okay, so inside we also have an O-ring that seals the connector, and a little bit of 50-year-old goodness that they use to give it kind of a seal. As you can see, it just flakes off. It doesn't do anything. We'll check the seal of that gasket when we assemble it quickly, and maybe we'll put a little bit of RTV sealant, but nowadays, I mean, most people don't drive these cars in the rain, but nonetheless, you do want to seal this. If water starts getting inside, you're going to have a fair bit of corrosion. So you can see this pin. This is what holds the adjustment bar, I guess you can say. I'm going to call this a bimetallic strip, but it's a bit thicker than your standard bimetallic strip. So it probably has very little movement. And there seems to be another bimetallic strip on top that influences or acts as a stop in some way, shape, or form. So we'll see. We have the old gasket around the outside. We'll pop that out. The kit has a new one. Let's just verify that it's the same size before we disassemble it, because it's probably going to get torn when we remove it. Yep, pretty close. So we will remove it. Oh yeah, look at that rubber. It's so dry and brittle. Yeah, it even smells like old fuel too. Okay, so we are now going to remove these 4 bolts, and that should release the this one. Magnetic screwdriver's got a couple little flakes on it there. Don't want to get any extra stuff in there unless we have to. And take your time. Some of these might be a bit stiff. Last thing you want to do is strip these in the aluminum, but sometimes you have no choice. I believe the new socket cap screws will replace these. We'll see what the length is like. Obviously that's a universal kit, so we'll check the lengths first, and I guess maybe people have had issues with these snapping, so they included 4 new ones in the kit. Obviously socket cap screws are a little bit more reluctant to stripping than a flat blade, but that's always hit and miss sometimes. So So we'll loosen all 4 bolts. There we go. Let me just grab my little screwdriver. Okay. Let's see. Get my fingers in there. Okay, we're just going to dump this out. I'd like to keep it in order so you can see the order that it comes out in case there's some little bits in there that would like to. I had way better pair of needle nose than that somewhere. Turns out use the. Come on. Okay, whatever. There we go. Okay, so we have the backing plate here that actuator pin sits in. See how that's a machined, machined precision surface. You can see how shiny it is too. When you have a almost mirror finish, that also provides a sealing surface in very precise applications. Here's the metering plate, or one of the movement plates, and we can see that hole was in this direction. It might not have any influence, but it's always ideal to try and keep these together as in the same direction as they came apart. So the kit does not have a spare one of these, so we'll have to be very careful about that one here. This is the diaphragm plate. It doesn't look too bad. Sometimes, because these are stainless plates, you'll see some wear right on the sealing surface right there where that nozzle is. So this is the inlet. Excuse me. Inlet and outlet, depending on how the fuel distributor is configured. And a very, very finite surface that allows very small pressure flow, fuel flow to adjust the pressure in the fuel distributor. So, and then we have an O-ring right here. So we will try and get that O-ring out without destroying the surfaces here. Always hard when you have 50-plus-year-old O-rings that do not want to come out. Always be careful not to scratch the surfaces or divot them. I'm just trying to loosen it up by shifting it around. Wish I had a smaller kick. I don't have one here, do I? No, it's okay. No. There we go. There we go. That's what I wanted to do. There. Old O-ring. Now, the kit. Ah, there it is right there. Okay, so you can see the old one and the new one. The old. Okay, I believe this does not come apart anymore. Let me just check it in the light. I've got a flashlight here, so I'll make sure that the passages are free. Yeah, and we can see light through the first one. Now the second one, we don't see any light going through it. Now it is at an angle. Now obviously the inlet hole's off to the side, and probably is a 90-degree bend in there some way, shape, or form. I was trying to disassemble this internal piece from the top piece. I don't know exactly if this whole assembly is one piece and pressed in. I'm led to believe that it is two pieces because this center hole is actually this port here, and because you can't see any light through it when I shine a flashlight from behind or above, there is a sharp angle in there, and there's no way to machine that in any sort of a process. So I suspect it's two pieces. However, it does not want to come apart. The only thing that could be in there is this O-ring, but diagrams show different. As you can see on this diagram here, it shows this top half assembly as one complete piece with a notch bracket holding it together. Obviously, this EHA is slightly different. They had many different versions. I call it an EHA, but this fuel regulator is warm-up regulator is different. Bosch had a whole bunch of different versions of these for different applications and different cars, but they all had relatively the same design. This one's slightly different. This might be an older gen or the newer gen. I don't remember exactly when the K-Jet ceased to exist and then the KE replaced it in various applications. Mercedes, Rolls-Royce, Ferrari used a lot of the Bosch K-style fuel systems. Porsche did as well, but Porsche also had their other fuel system. I believe it was, I can't remember, I'm not too experienced on the mechanical fuel injection pump system that Porsche used. Very similar to a diesel pump actually, but for fuel injection. That's the system that's more suited towards performance. The Bosch K jet system does have its limitations, especially as you start pushing the horsepower range of your motor. And adjustability for higher performance isn't exactly its strong point. These were more suited for fuel economy and meeting fuel economy standards, specifically even more in the US, so when the cars came to the US. So anyways, this warm-up regulator, I'm not going to try forcing this half out. I don't have a breakdown diagram specifically of this type of warm-up regulator. Ideally, maybe the only part that is in between those two halves is this O-ring, but I can tell you from experience this unit does not leak. So for now, we will leave it, and down the road, if we do start having issues, then we'll pull that apart. But the passages are cleared. We did blow them out to quickly check. We'll also be throwing this part inside the ultrasonic bath to give it a quick clean, along with the other parts. One thing to note, so this kit came with a new regulator plate to replace this one here. Unfortunately, because the way it was packaged, you can see there's a slight kink and dent right there. Unfortunately, that can cause severe issues of sealing against this surface and that inner port surface. We will not be reusing this part. Luckily, the original part is still in fantastic shape. There's no wear spots. The stainless shim material is very resilient, and we don't see any damage. That's just surface contamination that you see, but there's no wear spots that I can see. We can clean this up. It'll look good as new, and we'll throw that into the ultrasonic cleaner as well. And we'll do that now. We'll also throw this spring plate in there. There's a lot of crusty old 50-year-old grease in there, or 45-year-old grease. So we'll clean that out. We'll throw that in the ultrasonics, and the kit came with 2 new springs. We'll just quickly check the springs here, just check their heights. This is a bit of an interesting quest if you want to replace the springs. The springs that came in this kit do look to be almost the same. Let me just go check them on the surface plate here. They're slightly higher. The new ones are slightly higher, but that doesn't mean everything. The spring rate could also be different. Do you have the manual? Did this kit come with a manual at all?
No.
No? Okay. So now it's the question of, do we replace the springs or not? And the original springs are fine.
I think the original ones looks.
Yeah. You can see this. The spring diameter is significant different too. Yeah, and these most good quality springs have the top faces machined so they sit flush. The new ones do feel stiffer. You know what, we'll put the original springs back in for now. If we still have fueling issues after all the adjustments, then we'll put the new ones in. They do feel a slightly softer, so that might help with enriching under specific applications, a little bit more range. But for now, we'll leave the stiffer springs in, the original stiffer springs in, and we'll save these on the side down the road. The great thing is a lot of the not just Bosch, but a lot of the older German cars from the 70s, up to the early 90s. I want to say 91 from my experience with the Mercedes stuff. A lot of the components are very rebuildable. AC compressors, power steering pumps, alternators. They design these cars to last a long time. So assembly and disassembly is actually pretty straightforward, and they're designed to be assembled and disassembled. Not too many times, but at least they give you the option to be able to open a part up, change something, put it back together. A lot of modern cars nowadays are designed for speed, efficiency, as far as production of parts. So they have either a crimped surface, because crimping a surface is much less expensive and time consuming than screwing a surface together. So that's one of the great benefits of owning and working on a classic German car. So we're going to throw these parts in the ultrasonic wash, and we'll come back. What I'm going to do now is the modification for giving the regulator some adjustment, external adjustment. So we will be machining the mount pin that's threaded on the other end that holds the bimetallic strip. We'll give more details after I'm done machining. So right now we're just going to drill a number 19 drill bit, and then use a M5 by 0.06, sorry, 0.08 tap, and we'll go down 10 millimeter or 400 thou, and tap it and drill it, and then we'll assemble it on the bench there, and I'll show you how we get from there. So, and then I crank the table up. So we gotta do this nice and slow.
So what are we now? We did the 10 millimeter.
Recording? Yeah. Yeah, we did the 10 millimeter depth hole, and now we are going to just lightly tap it and take it easy here. There we go. Reverse.
So this is where you put the screws, right?
Yep.
That's where you get the.
There we go. Okay. Okay, and we'll clean it up and we'll show it on the bench. Okay, so we have our parts back from the ultrasonic. They cleaned up pretty well. Before we start assembly, I just want to quickly show. This is the hole that we drilled and tapped. It's a number 19 drill and a M5 tap. And what we did is very similar to as shown in this diagram. Now you have a screw with a washer and a nut to allow you to slide this pin in and out of the body for fine adjustment. You would tighten the bolt to pull the pin up and out. You'd loosen it, lightly tap it to move the pin in, and as you hear, it says move out to raise cold pressure, move in to lower cold pressure. So we're just going to quickly show how the assembly goes, but we'll actually assemble it properly once we're done putting the modulator regulator together. So here's a M5 bolt. Ideally you want to use stainless, however I don't have any stainless at the time. So, and then a double nut I believe will work on this length. Let's see here, yeah. Put the double nut in, thread it in. So right now it's just the factory setting, and we won't adjust it until we have the car on the dyno. So yeah, that's basically how the finished assembly would look. And it's always ideal to use stainless nut in this application with a little dab of blue low strength Loctite would help to prevent vibration if you don't have the space to double nut it. So here we're going to assemble the the top half, sorry, of the regulator, and you can see our handy little holding device here, precision holding device. That makes it easy for when you start stacking the stainless plates in there for the diaphragms. So first things first is we're going to put the washer O-ring in, sealing O-ring, sits in there nicely. This is the new O-ring. The first plate does not have any holes, and you can slightly see we're going to reuse the original plate. The new one has some creases in it that came with the kit. The old one's in good condition. There's not any deep scratches, creases, or anything on here. You can slightly see a wear mark from the that surface right there, so we know that this faced down, and we will drop it in and get it roughly aligned. These plates do like to move around, so this is a bit of a challenging part when assembling this half of the diaphragm. Here we have the diaphragm with the hole. The hole faces in the direction of the bimetallic strip, and because of that it only lets you really put it in one direction because these holes are offset. So this sits in this direction, and then this little cup sits on top. We have a little dab of grease on the bottom just to hold it in place during assembly. I actually have some grease inside this cup here, fresh grease. Let's put a little dab there. That will hold this in place during assembly. And we will sit it down like so. And help with alignment here. There we go. Okay, now the cover plate goes on. Check it's nice and clean. And we'll try and drop that cover plate on there. See if I can do it by hand. Make sure that that cup pin is in place. Where's my pick? Here it is. And we'll try to get the plates aligned as close as we can so we can start passing the bolts through. Okay, once we get one bolt in, we'll be able to get the rest of them. Now, the kit did come with some socket cap screws. These would be ideal to reuse. However, they are slightly longer, and I believe they will bottom out when we put them in. So we won't be using these. We'll reuse the original flatheads, and we'll put the first one in. Should drop right in just like that. Now, actually, I'll use the pick. I'll use the pick, line up our second hole, make sure all the plates line up. There we go. And then we can drop our second flathead screw in. There we go. Do not want to force it in or you will bend the plates and then you'll have a leak. So we'll drop the 4 flathead screws in and we'll tighten it up. Let's use our little screwdriver for now and just snug them in a crisscross pattern. Okay. There you go, just snug them down. There you go. Then we'll come in with our larger screwdriver and tighten them up. Okay, get the bigger screwdriver out. You don't want to go crazy tightening it, but just go in a crisscross pattern. And give them a bit of a snug. You don't want to go too tight. These are, I believe, an M3 thread, and they will strip very easily if you overdo it. Okay, next we're going to put the bimetallic heating element in. That O-ring that we were looking at earlier, the orange one, is actually the seal for the connector. So we'll put the bimetallic strip in with the raised indents facing up, but if you don't stretch the wires, you'll see it naturally falls into place like that. We'll just lightly put the washer, lock washer, and the M10, sorry, not the M10, the 10 millimeter nut. I believe it's an M6. And just lightly snug it in place. Center it, and then we can put the clip on the other side. We are done with our precision holding device. And we will put the clip on. Clip is always a bit troublesome to put on. Be very careful you don't crack the connector. Try and push it on as far as I can manually without stabbing yourself. There we go. There we can come out with the big pliers. Squeeze it on. There we go. Clicks in. Nice and clean. One thing to note, remember when I was machining it, I had some electrical tape on here. You do not want any particles getting inside of these holes. There's very small orifices inside. You get a piece of metal shaving or whatnot in there, that's it. You'll never get this thing to work, and you might not ever be able to get the garbage out of there. So, yeah, okay, this side looks good. And now the fun part. We'll put the pin in after when we're ready to assemble the halves.
You want to put
the gasket, yeah, we'll put the gasket on now. So I just lightly grease the gasket up and fits it into place. Can be a bit tricky to get in. There we go, great. Okay, we'll put that off to the side. This is the bottom half of the regulator. You see this diaphragm fits on top like so. Make sure there's no creases. Bottom half assembles this way. Okay. Make sure our gasket is as close to lined up as possible. And you want to make sure you get this center diaphragm piece as centered as possible. We'll assemble the large spring, the small spring, and then the cone cap that goes on. Actually, one thing that's interesting to note is the way this bottom half is designed is the center small screen provides atmosphere calibration to the fuel system. You noted, as I noted earlier, I believe in another portion of the video. This is open to atmosphere and allows the center spring to compensate the fuel slightly, warm up regulation aspect of it in relation to ambient atmospheric pressure. So it moves in and out slightly depending on pressure changes in relation to the inside chamber pressure, and will slightly compensate the center spring to the cone plate. So before we assemble the two halves together, you want to put a generous amount of thick grease in this bottom cup. The original factory did have grease in there, and you also want to put a dab of grease on the inside cup here for that pin to stick to. And the reason we do that is so that the pin, I already have some grease on the pin here, the pin needs to be held in there as we turn the assembly upside down and kept straight so that it will seat into the center of that cup when we put the two halves together. So we'll just sit that pin in there. Yeah, it stays in there. So we want to flip it up so the pin doesn't fall out. So this is where we're going to assemble the two halves together. Obviously, if we lift this up, it's all going to fall apart. So we'll just quickly tip it, pin doesn't fall out, slide it over, and done. And how we can tell that the pin did seat is this half does have a slight springiness to it, meaning that the pin is now received in both ends of the cups, and we are lined up and ready to go. So we are going to put the nuts in here. There we go, one there. We're just going to assemble it, just quickly get it held together here. A bit of a tricky assembly because you've got three halves that want to slide about. I'm just going to tighten the screw off camera. There we go. Okay. Just lightly snug it. You don't want to do a full assembly right now. You just want to get everything lined up and in place. Okay. These two center holes are where the socket cap screws, oh, one just fell out, bolt onto the motor. Okay. Here I am fumbling around. There we go. Lightly snug that. Okay, now we can hold the assembly upside down and tighten it with our larger screw. What is that on there? It's a piece of fluff. Okay, and you want to snug it, go across, snug it, go across, snug it, go across. Check, make sure your gaskets aren't pinched anywhere, everything looks good. Okay, now we can do a final tightening. Okay, so that is now assembled and finished. We will do two quick things. Actually, I'll put these washers, these crush washers back on when we assemble the unit back on the car and have it on the dyno. So that's what these are for. Obviously, different regulators use different washers, but I believe there's 3 in total. 2 of them are used on, the 2 small ones are used on this bolt here that goes into this cavity. Actually, what I'm going to do is I'll put the washers on there so they're on there when we put the regulator back on the motor. Because it's a, I believe they call it a banjo bolt, a banjo style fitting that comes off the side, and the crush washers are on either side of that angled fitting. And we'll just put one new copper crush washer on there. Make sure no fluff gets in there. Okay, so we'll tighten it down. All right, so this basically is rebuilt. What we're going to quickly do right now is I won't be putting a blue Loctite on this at this time. Once the engine's on the dyno, we'll be fiddling around getting it adjusted, and then we'll lock it down and do some more dyno pulls from there. So I'm going to put a washer, 2 lock nuts, and an M5 bolt. Snug. It's still at the factory setting. We didn't move it around or anything during machining. And now we have a completed, rebuilt pressure regulator ready for testing.
Check the the ohms meter with it.
Yeah, we can do that. We can do one final check, make sure that the heating element didn't get damaged during assembly. There we go. We got all that. Okay. Alright, so turn it on. We'll put on continuity. You even put it on resistance, so 200 ohms, but continuity does the same thing. Check it. 37 ohms, so we're spot on. 36.
Okay.
So we're good to go.